Hey, had to tell her she should act right. She just wanna talk about the time we had last night.
At the ribbon for your feelings. The way she suck my spine is a spiritual healing.
Good morning, students. I am Rex Estrada Obida, 21 years old, from Western Mindanao State University, Ipil Campus. Would like to express my deepest gratitude of inviting me to be your speaker at this very important event of Mathematics Month. So, what is mathematics? So, we have a lot of variety of definitions coming from famous mathematicians, famous professors, famous authors, famous schools, etc. And all the definitions that have been given by the different persons and institutions are all true about mathematics. So in short, or in summary, mathematics is a form of art that deals with numbers, logics, equations, and expressions that are applicable in a real-life situation. So, many of you wonder why math is part of our daily basis. Well, it is because all the infrastructures, things, tools, and equipments, and etc. are connected with mathematics. Especially, it deals with measurements and exact calculations to make it useful and not harmful to human beings. So, can I ask a question? What was your topic in math before this important event happened? Okay, thank you. So, what have you learned about the topic? Alright, so do you find it interesting? Okay, thank you so much for that. So, moving forward to that, let me present to you my objectives of this lesson. At the end of the lesson, the students are able to identify arithmetic progression. Second, solve problem using arithmetic progression. And the third, show real-life scenarios that involve arithmetic progressions. So, obviously, our topic for this lesson is all about arithmetic progressions. So, before we touch the arithmetic progression itself, let's have a background knowledge first about sequence. Okay, let's take a look at this video.
A sequence is simply a set of numbers in a particular order, or a set of numbers which follow a pattern. The most basic example of a sequence is that of counting numbers. 1, 2, 3, 4, and so on. The numbers follow an increasing pattern. The 3 dots mean the list goes on forever and are referred to as the ellipses. The numbers don't necessarily have to be continuous to be a sequence. A list like 0, 5, 10, 15, and so on are also said to be in a sequence. What's the pattern here? Every number is increased by 5 to get the next number. A constant increment of 5. Let's take an example of a sequence which has an increment of 2, like 1, 3, 5, 7, 9, and so on. For your exams, there are just 2 things you need to know about any sequence. First, how do you find the nth term of a sequence? And second, how do you define the sequence? What do I mean when I say the nth term? Say I ask you the 31st term of the sequence. You have no time to write all the 31 terms to find that out. We need to have a formula, and yes, we have one. It is the first term plus n-1 times d. ft is the first term, n is the term number. So if we want to find the 31st term, we just substitute 31 in place of n. And d is called the difference between any 2 continuous terms. It's called the common difference. It's extremely simple to derive this formula, but you don't really need to know it for your exams. So don't dwell too much over it. In this example, as the first term is 1 and the common difference is 2, the nth term will be 1 plus n-1 times 2. How do we define a particular sequence? We just solve this further. Expanding this gives us 2n minus 2 and we add the 1. This gives us 2n minus 1. Here, n takes the value of all natural numbers? Don't forget, n is the term number. If we call this sequence S, the first term of the sequence will be written as S1. To find the first term, all we do is substitute 1 in place of n. We get 2 times 1 minus 1. And 2 minus 1 gives us 1. Now with this formula, try finding the 9th and the 21st term of the sequence. The 9th term will be 2 times 9 minus 1, which equals 17. And the 21st term will be 2 times 21 minus 1, which equals 41. 41 is the 21st term of this sequence. So to define the sequence, we just use the nth term formula and substitute the values of the first term and the common difference.
So, sequence. It is a succession of numbers in which one number is designated as the first, another as the second, another as the third, and so on. It's called a sequence. Each number of a sequence is also called a term. So, let's have an example. So, let the succession of number 4, 7, 11, 13, 16 be in order as the first, the second, the third, the fourth, and the fifth as arranged from a sequence. So, let's have another example. Let us specify that the numbers 4, negative 3, 9, 7 appears in the order from first, second, third, and fourth. Then, the succession of the number forms a sequence. So, if we let A1 stand for the first term of a sequence, A2 for the second term, A3 for the third term, and so on, we can denote the sequence by writing A1, A2, A3, dot dot dot, AN, and dot dot dot, and so on. So, the term AN is called a general term or the nth term. Now, suppose the expression is given in terms of n, by which the terms of a sequence can be obtained by substituting 1, 2, 3, and so on. We indicate the sequence by sequences 1, 4, 9, 16, 25, dot dot dot, and squared with the infinity symbol. So, as another example, let an is equals to n over n squared plus 1. So, terms of this sequence are 1/2, 2/5, 3/10, 4/17, 5/26, and n over n squared plus 1 with the infinity symbol. So that is the definition of the sequence. So, we all know already the sequence, that it is a succession of numbers, that there are a series of numbers that are being arranged. And now, let's proceed to the main topic of this lesson. Okay, let's take a look at this video.
Arithmetic sequence. The formula of arithmetic sequence is A sub n is equals to A sub 1 plus the quantity of n minus 1 times d, where an is the nth term, a1 is the first term, n is the number of term, d is the common difference. For example, find the 21st term of an arithmetic sequence, 3, 7, 11, 15. So our given here is a sub n is 21, because 21 is our nth term. A sub 1 is 3 because 3 is the first term. N is 21 because 21 is the number of term. The common difference is 4. So here's the solution. A sub 21 is equals to 3, plus the quantity of 21, minus 1 times d. So it will become A21 is equal to 3, plus the quantity of 20 times d. A21 is equals to 3 plus 80. 3 plus 80 is 83. So the 21st term is 83. Another example. Find the 10th term of an arithmetic sequence, 1, 5 over 2, 4, 11 over 2. So the given here is, a sub n is 10, because 10 is our nth term. A sub 1 is 1, because 1 is our first term. N is 10, because 10 is the number of term. And our common difference is 3 over 2. Take note. To find the common difference, you have to subtract the second term to the first term. So it will become a sub 10 equal 1, plus the quantity of 10 minus 1, times 3 over 2. So a sub 10 equal 1, plus the quantity of 9, times 3 over 2. Okay. A sub 10 equal 1, plus 13.5. The answer is 14.5. So the 10th term is 14.5.
And now, we're going to talk about arithmetic progressions. So, arithmetic progression, it is a sequence in which each term after the first is affirmed by adding a fixed number to the preceding term is called an arithmetic progression. The fixed number is called the common difference. Okay, so let's have this example. So, the sequence 2, 5, 8, 11, 14. So, it is an arithmetic progression. Obviously, we have the common difference of 3, where 5 minus 2 equals to 3, and then 8 minus 5 equals to 3, 11 minus 8 equals to 3, 14 minus 11 equals to 3. So, we have the common difference of 3 of the given sequence. So, let's have another example. So, the sequence 10, 7, 4, 1, negative 2, and negative 5 is also an arithmetic progression. Although we have the sequence, we have given negative numbers, so we also came up with the common difference of negative 3 because we start from the bigger number subtracted by the smaller number. So 10 minus 7 minus 10, so we have the answer of negative 3, and then 4 minus 7, negative 3, 1 minus 4, negative 3. So we have the common difference of negative 3. So did you get what am I trying to impose to you, that arithmetic progression deals with common difference by the sequence it produces. So no matter if the common difference is positive or negative, as long as all the sequence given number produces a common difference. If A1 stands for the first term and D for the common difference of an arithmetic progression, we can write the successive terms by repeated addition of its common difference. Thus, the n terms we can write A plus A1 plus D, and A1 plus 2D, and A1 plus 3D, A plus N minus 1 multiplied by the common difference. So, we have AN equals A1 plus N minus D, I minus 1 times T. So, with A and D given, we may find an desired term of the progression by substituting the proper opposite integer for N. So, let's have an example. So, find the 30th term of the arithmetic progression 2, 6, 10. So we only have 3 numbers in a sequence and we're about to locate its 38th term. So we have the solution. So for A1, which is the first term, the 2, and the D, if you're going to subtract from second term by the first term, we came up with the 4. So we have the common difference of 4. And our N is equals to 30 since we're looking for the 38th term of the sequence. So, by using the formula for AN. So, we find by substituting the given to the formula. So, we have AN. So, we're going to substitute it by A30. So, equals A1. So, the A1 is 2. And then N minus 1. So, we have the N 30. So, 30 minus 1. And D, so the D is 4. So we came up with 2 plus 116. So if you're going to add that, we have the the outcome of 118. The first and the last terms of a finite arithmetic progressions are called arithmetic extremes, and the terms in between are called arithmetic means. So, if you wish to insert a certain numbers between the two given numbers, we employ the formula for an to find the d. Then, the terms of the progression can be written by a repeated additions of d or the common difference. So in that situation, let's have an example. So, insert 5 arithmetic means between 7 and 25. So, we only have two given numbers sequence. So, from the 7 to 25, so it has a long range in between, and then we're asked to find the 5 arithmetic means in between. So, in that case, so our A1 will be the 7 since 7 is the first number given. Our AN will be 25 since 25 is the last terms. So the terms of the progressions consist of the two given terms plus 5 means giving n is equals to 7. Substituting in n formula, we find 25 is equals to 7 plus 6d, and then d is equals to 3. So the progression is 7, 10, 13, 16, 19, 25, 22, and 25. So in the given sequence, we find the the 5 arithmetic means by the sequence given. Formula by adding the sum of the terms of an arithmetic progressions. So from the first term, we have Sn is equals to A1 plus the product of A1 plus D plus the product of A1 plus 2D plus dot 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 plus An is equals minus D plus An. So from the last term, we have Sn is equals to An plus the product of An plus D plus the product of An minus 2D plus dot 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 plus the product of A1 plus D plus An. Adding the member of two equations, we get 2 Sn is equals to the product of A1 plus An plus the product of A1 plus An plus the product of A1 plus An plus dot 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 the product of A1 plus An plus the product of A1 plus An. Since the progression has n terms, the sum of the product of A1 plus An appears n times, and therefore Sn is equal to n over 2 multiplied by the product of A1 plus An. We obtain another formula for Sn by substituting formula for An. So we have Sn is equals to n over 2 with quantity of multiple number of A1 plus the product of n minus 1 multiplied by D. So the formula for finite arithmetic, so we have An is equals to A1 plus n minus 1 times D. So for Sn, we have n over 2 multiplied by the product of A1 plus An. So, or the other formula, we have Sn is equals to n over 2 with a multiple numbers, with a multiple group of numbers multiplied by 2A1 plus the product of n minus 1 times D. So, the five quantities A, An, D, N, and Sn are called the elements of an arithmetic progression. So, always put in mind that arithmetic progressions, it is a succession of numbers that has its common difference. So, can I ask the students to just prepare any sheet of paper? So, let's just perform this simple activity. And then, after 5 minutes of doing the activity, just send your answers on the chat box. Okay?
Hey, had to tell her she should act right. She just wanna talk about the time we had last night.
That bit been